So hello everyone, welcome back to our Intro to R workshop. This is day 2, and I think we can just start. So here is the notation of the slides as usual. And for yesterday's workshop, we actually have covered some kind of basics about R, getting the environment set up, also have some understanding knowledge about variables, operators, and some of the data structures, specifically the vectors. So we still have something left to do is try to learn the flow control, the loops and the functions. So basically we are going to learn those for today. And in addition to that, we will also learn some advanced topics. So specifically for the file input output, like from your downloaded file, how we can import them into the R environment. And then starting from there, we will move on to learn some data wrangling using the tidyverse toolkit. So later on, we will talk about what is the data wrangling and what method, what functions we can use. So again, like this is a 3-hour workshop. We are going to have a 15-minute break after every 45 minutes. And sometimes we probably will end early, but I don't think that's the case for today because we have a lot of things to go over. So for today, we will finish the data structures about the list and the data frame. And we are going to learn those like how to write the code in R that enables some functionality. And lastly, we are going to learn some data wrangling tricks. So before we start, I want to give some short summary about what we have learned so far. We have for yesterday's workshop, we have learned what is a variable. So basically, you can consider it's a container of the data. Showing in the right picture, each of the container has a name, the variable name, and also it contains some values. So basically, we cover a lot of like which seems important details, but actually those are very important. So for example, the naming rules, especially when you write a lot of code in just one R script, you want to like get things organized and make the code as clean as possible. So you probably need to consider how to name the variables well. And we also talk about the value assignment using the equality sign or using that assignment sign. We also talk about the variable classes, the integer, numeric, the numbers, was character, factor, etc. We also know how to inspect the variables just using the print to print the values and using the head function when your data is quite big, if you print it out, then it will take forever. So you can just get a peek of the data. So we also talk about how to inspect the workspace, like using the ls function. You can list all the variables and the functions in your environment. And you can use the remove function to remove some variables. And you can using get WD to get the working directory, etc. So in addition to that, we also talk about the number representation in our computer system. Specifically, we talk about the range, like using R, we're using other computing language. The range of data is limited. It's not like infinity. We cannot represent number that approaching to infinity or something. But luckily for our daily usage, those numbers, like although it's limited, but it's still like enough for our daily usage. So here is that we introduce the rationale behind, and also in yesterday's workshop, we showed interesting phenomenon about the rounding errors. Actually, it's a result of this representation. We also talk about the special numbers, specifically for the infinite number. the missing values NA and the Norton number NaN, and some other interesting numbers like imaginary number and the pi and natural exponential base. So basically those are we can consider R is a computing environment. We have those built in, so you can just use it. After we learn the variables, we also talk about the operators, which defines the actions on variables. So basically, we talk about the arithmetic operators, plus, subtract, times, division, etc. We also talk about the relational operators, greater than, equal than, or like smaller than. We also talk about the logical operators and the or and the not. And we will learn about the operator's precedence, like when you are writing a compound condition. So if you're not sure like which variables, which part of your formula will be computed first, then you can take a look at this table and see what's going on here. And you can always use a parenthesis to enclose the part you want to compute first. So this is like a small trick. And we actually yesterday we also learned how to use RStudio. We get familiar with the interface of RStudio, get the environment set up, and we also see some interesting example if you still remember the Euler's equations. So in the last part, I think yesterday, is that we talk about the R objects, the data containers. Specifically, we learned the vectors, or strings, factors, and the matrix. So this so basically it's like everything we talk about is just one data type, a single type, like a vector. All the elements in the vector should belong to the same type. Like either it's a numerical type, integer, or the characters. So based on the type, like we can also have a vector of strings, and when the strings they have some kind of duplicates there, we can actually store the strings into factors, and just storing the whole data as a factor, which is the numbers with labels. The labels is the string. So lastly, we talk about the matrix, which is sometimes we love it because it's really how our data really look like. For example, the gene expression matrix, everything it's a numerical value, and you have the rows, you have the columns standing for the genes and for the samples. So basically, those are just for the single type, and for each of the objects, we have the functions to either create the object, to reference to them, like just get a small part of the data using the indexing. And based on the indexing, you can actually do some update. For example, you can assign a new value to the existing objects. And if you have multiple objects, you can merge them. So each of the vectors or the matrix, you have some associated functions. And for today, we are going to learn the right part, the list and the data frame. So which is the multiple types. So here is like a small illustration, like each of the color denotes a data type. So vector and the matrix, they will have the same color within the object. The list and the data frame, they can have different colors, but there are something different here, which so basically you can clearly see that the data frame, each column, they have the same color, which we will talk about it later. And the list is a more generic data frame. It has a very flexible length, very flexible data type. It can either be like a list of lists, a nested list. So basically, this one is quite useful when you are storing some data. But when you are computing, like then this list probably is not a go-to data data types. So for the first thing about the list is to create a list. So a list is loosely speaking a vector, but each of the element can be a different type. As I said, the different type can be anything you can think of in the R world, either numerical, integer, character, or even the list itself, or even it can be a matrix, a data frame, etc. So if you want to create an empty list, you can use a vector function, which we mentioned yesterday. And if you want to create a list with assigned values, you can use the list functions. Here I just showing the list ABCD. ABCD can be your variable names. They contain some data inside. So in the right panel, I actually show each of the elements ABCD. They can be in the different types. For example, some of them will be the vector, numerical vector, and some of them can even be a function, like a sum here, and some of them can be the matrix. So when you first create the list, you can actually assign the names to each of the element. So basically what you need to do is just try to put the names on the left-hand side with the equal sign and put the values on the right-hand side. So each of the element will be assigned with a name. And if you want to rename or add some names to the existing list, you can still use a names function to do that. Just pass the character string, character vector, string vector into the names of this object, this list. So basically, the final results will be you are actually renaming the whole list. Like each of them can have a new name now. And for the dimensions and the arithmetics, as we said, the list is actually just a vector, but each of the elements can have different types. So just like vectors, list have the length. If you can using the length function to get how many elements in the list. So this one, because we know that the list can contain different types of data. So this length will be only the top level elements. It will not account for the, for example, from the first element, it's another list. So basically it will only count it as one element, not like the nested element. And just like vectors list, we can consider it as like a one dimension. So basically, if you run the dim function, it will return null. And as we said, list is a very generic data container. Each of the elements, they have different types. They probably have different types. So basically, with the list, the arithmetic doesn't really make sense in some way, because we know once we have the data type, we can define the arithmetic operations. But even if your data types is uncertain, is dynamic within the list, then you don't really know what kind of arithmetic it supports. So this is the natural result that the list doesn't, the arithmetic functions doesn't work on the list. So another important part about the list is we want to access the elements inside. This is so-called indexing. So we can use a single square brackets to access the, for example, from the number 2 elements to number 5 elements. So after you running this, it will return the indexing operations will return another list. So this is something keep in mind. And if you really want to get into the element itself, you should use a double square brackets to actually get into the element itself. So for example, here in the left-hand side, we define the list, and if we use a single bracket, we will get the first 2, like 1, 2, 2. So this will give us a vector, right? Like 1 column 2. This will give us a vector, the index vector. So it will actually return a list containing the first two elements. And if we want to access what is the very first element, we should use the double brackets with 1. Or sometimes if it's a named list, like here, you can also put the names here. So this one will give you the value 1. It's a vector. And for the named list, you can also use the $sign to access the element. So basically, you can use the $sign, put the name here. It will also return the first element's value. And if you want to combine the list or remove some element, you can consider using the C function we talked about. So this C function is useful when you are working with the vector, but here you can also use it with list. So this will concatenate the two lists into the final list you have. And if you really don't like some elements in your list, you can try to delete it using this trick that you can set for example, set some of the variables, like for example, the element B with the name B, set it to null. So this will completely remove the element from your current list. So actually, I have a question for you guys. Do you think there is any difference, or do you think they are the same between null and NA? Or do you have any idea about is there any difference between them? So, no idea. Okay, yeah, no worries. So we talked about the NA yesterday, that it actually exists, but we just don't know the values. So we call it as a missing value. So it's something existing, but we don't know. But now is that something is not existing. So if you, for example, if you run the length function on the null value, if you have the RStudio open, you can just run it right now. So it actually give you 0. So meaning that this is not an element. This is not an entity. It just stands for nothing. So this is the whole like the difference between null and NA. NA is something existing, but we just don't know. But now it's like it's not even existing. So I hope this is intuitive here. So that is about the list, and the next thing is about the data frame. So data frame, as we saw in the previous picture, that it actually shows some kind of spreadsheet-like data. So basically, I think it's like our favorite data in our daily life. When you collect samples or you have a record about a patient or something, it's always like we opening up an Excel sheet, and so it's kind of a two-dimensional. It's the spreadsheet-like data. So you can consider the data frame as a matrix, because matrix is also two-dimensional, right? But you have each of the column to have the same type within the column, but between columns they can be different types. So for example, in the Excel sheet, we have the column called the height, which is the numerical value, like from 0 to 5'7", or some other values. And you have also other columns denoting, for example, the gender of the person. It's male or female, it's a string. So within each of the column, like across the observations, across the patients, they are the same value. But between the columns, different variables, they can be different types. So this can be, this is just one way to visualize our data frame. They can be considered as a matrix in some way. And they can also consider the non-nested list where each element is the same length. So how to understand this point is that you can consider the data frame is a list of observations. Just still take the Excel table as we as we are familiar with, that each of the patient is an observation, and it contains some traits like height, the gender, etc. So basically, you can consider this whole data frame is a list, and each element is a patient, and this patient they contain is another list. They contain different traits in the list. And in the data frame, we actually call the rows as the observations, which is shown here, the horizontal, and the columns are the variables. So this is like a convention tradition we will usually refer to the observations and the variables, and the values in the cells it's just called the values. Okay. So to create a data frame, you can use a data frame function to do that. Specifically, you call this function, you assign the values to a variable. And here we have two variables. And as you can see, the two variables, they can be different types, but within the variable, it's a vector. So the vector, we know vector must have the same type. So this is something different from the list. That the list can be different types, but in here, each variable must have the same type. So for the data frame, we can also do some add some names when creating the data frame. So specifically, when we specify the data frame, like when we try to define a data frame, we can put the row names. So it has an argument, row names. You can specify it by a string vector to it. So basically, this will give you the row names. And for existing data frame, you can access the row names or even set the row names using this function, the row names function. So here I show a small example. You first define the name the data frame, just specifying the row names as an additional parameter. And then if you want to access them, you can run the row names, or sometimes you can assign a new vector, new names, like just using an equal or assign symbol and put your vector of names here, and then it will actually update the row names for you. So the columns is similar. You can use something like the call names to do that. And you can get both the column and the row names just using the dimensional names. It will return a list of names. The first one is a row name, second one is the column names. So another thing about the column names is that when you're creating it, it will try to check whether the variable names to be unique. So I think the unique things is what we really like in analysis, because if there are two columns, two variables, two have the same name, we don't really know, okay, which one will be the one, like you have some ambiguity there. So basically this, when you are creating the data frames, it will actually do some checking. And if you don't really want it, so you can specify check names to be false to suppress the behavior. So by default, it will check the names to be unique. And for the data frame, we can access the dimensions using the n-row, n-column, just trying to get how many observations and how many variables in your data. You can also use the dimension. So this is exactly the same as the matrix, because we know that data frame can be considered a special matrix. And for the indexing, we still have the very similar thing as the matrix indexing, that you can pass the 4 different vector indexes to it. So basically, you can put the positive integers. It will try to get the like a position one row, 2 rows, 3 rows. Like this is the positive integers. And if you put the negative integers, it will try to exclude that column or that variable. And you can also put the logical values indicating if it's true, then indicating we will we will obtain this row. And you can also put the characters if you have the row names or column names specified. So basically, these are the 4 different options we talked about yesterday about indexing the vector and the matrices. So they are still applicable here. And if we consider the data frame to be a nested list, then we can also use another way to index using the list indexing. So here, you can use the double square brackets to access a specific element, specific observation. And then because the observation will be another list, so you can actually put like using additional like indexing, just treat the double brackets give us a list, and then you can again index on the list to obtain the values. So besides the double brackets, you can also put the $sign to get the variables. So here is just like 3 different small example showing here. You can use the double square or just using a $sign. So these are so if you still remember about the list indexing, so this is these 2 methods, these 2 approaches are exactly what we use for list indexing. And if for just one, so we know that each of the data frame, each of the variables will be in the same type. So if you only specify one column, like you are indexing, you are selecting just one column, so the results will no longer be a data frame for you, but just simplify it to a vector. And if you do want like a data frame with just one column, what you can do is try to input the selected values, the selected vectors into the data dot frame function. So that in that way, you just like create a new data frame that has only one column. So besides the indexing, we can also use a function to subset the data frame in some way. So basically here, for example, you can try to use the conditions on the columns. We remember that we said that indexing, you can input the logical values to subset the data frame. So here, the subset is what we actually doing here. Like you are trying to get the y value from the data frame, compare it with the 0. So basically, this will give you a logical vector. And the second part is also it's another value, and you put a or operation here. So basically, the whole thing just gives you a true or false vectors, and we specify it as the rows indexing vector. So basically, this will tries to give you the select the rows for you, and then you can just put if you put a single variable here, it will try to extract the particular variables, and as a result, because we only select one column here, as a result, it will return a vector. So this is why in the end you see a vector here. So besides that, you can if you consider like you have a lot of like conditions here, then your line of code will be super long. So right now we have 2 conditions, and the line of code is long enough. So you can actually try to specify, like try to shorten or make the code much cleaner, just using the subset function. So it will take 3 arguments. The first one is a data frame to work on, and the second one was yeah, the second one will be just like a logical vector. So here you don't need to specifically extract this value, but simply just using the variable's name greater than some value or z. So basically you don't really need those $sign to extract the values out. And the third column is just a vector of column names to keep. So right now we only have one column, so just put the names here. So if you don't specify the third column, it will by default select all the columns for you. So this in this way, we can also do the subsetting. So this is particularly useful when you are have a giant data frame, like it's metadata, but you are only curious about some of the observations. For example, just take the Excel example. We sometimes want to split the male and the female and do a separate analysis. So this is the way we can try to do the splitting. So there are also some other functions we can use to on the data frame. For example, we want to transpose the data frame or transpose the matrix. This is useful when you are, for example, in the matrix, we want to calculate the covariance matrix. Then you will need to compute the inner product between a matrix and the transpose of another matrix. So the T function actually can do the transpose. And then remember that because of the data frame, they can actually have different variable types. So when you transpose, then the columns will be the rows. So the rows will be the columns. And because the rows, the original rows, they probably have different values. So when you are converting them to be a column, then to ensure that it is still a data frame, the columns must maintain at the same type. So basically, you will see that there are some kind of conversion going on. Just consider the example that right now you have the rows as the samples and the column as the gender and also the numerical value like a height of the person. So when you transpose the data frame, you will actually see all the values will be a string. Like even the height, it will be automatically converted to the string. So you can actually try it on your own to see if it is the case. And later in the tutorial in the R Studio session, we are going to see whether this is the case. And you can also combine the data frame. If you have multiple data frame, you can use the cbind to combine the data by column or rbind, combine the data by row. So this is like two basic operations. In the data wrangling part, we are going to talk about more advanced usage of how to combine the data frames. And sometimes we are curious about how to calculate the mean for an entire row or entire column. So you can use these two columns. Like for example, you have the height column, and you want to know, okay, for the male, what's the average height, and for the female, what's the average height or weight. So these are two useful functions you can use. So you don't really need to write a for loop, try to add everything up, and then divide by the total number of observations. You can just using the functions here. All right, so I think that's everything about the data structure we have in R, and I think that's pretty much about the basic R part. If you are like working with like developing your own packages, you want to define a new class. So basically, those will be like a next level, like advanced level of R, and you can refer to the advanced R reference book I posted yesterday. Like there are 7 reference books. I remember one of them is the advanced R. You can refer to that book. That book has a very detailed detailed description about the R structure, the data structure part, and how R dealing with those like down to the AS details. So you can actually refer to them. And the next part we are going to learn about is the flow control. So I think this one is what we are facing every day. Like you always need to make some decisions based on your current situation. So just like here saying, okay, if you don't really want to do your homework, you probably have all kind of reasons to not doing it. For example, do you have homework? No. Definitely this is not true, right? You're lying. If yes, and then you are asking yourself, is something else you want to do? So yes, then you do something else. But if it's like you only have the homework to do, you will consider, okay, it's a homework due in the next 12 hours. If yes, then you have to start working. If no, then you watch TV, you check email, etc. You do a lot of works. So basically, this is a typical example in your real life, the flow control. But in the R programming environment, we actually also have something similar. Like we can control the execution of the command or execution of the code, not from one to one, but we have some kind of judgment first, and then decide whether we want to do this or we want to do another thing. All right. So this one, I think in almost all the language I learned, they have this kind of if statement. It simply tries to judge whether right now a current a certain condition is satisfied. If it is satisfied, the condition is true, then you are going to do something. If not, then you just escape this action. So here, it's a syntax about if statement. You simply just put the condition within the parentheses behind the if, and then you have this curly bracket to enclose the if body. Like if it's true, then you execute this part. So this one is just like a very, I think it's kind of a straightforward, simple way to write the if statement. And remember, this condition must be true or false value. So it must be like you are doing some kind of a relational comparison. If this value is greater than 10, then you do something. Otherwise, you don't do the same. So basically, this condition is like a judgment. It gives you a true or false. And remember that the value cannot be a missing value, because missing means we don't know it's true or false. So this is not allowed in the if statement. And another thing I want to mention is that the condition here must be true or false. So basically it means it only have one value. So if you have multiple values, you can consider using the or any, like those two functions we talked about yesterday, to finally like combine all the true or false vector into just one value. And sometimes we don't really want to just escape. So if the condition is not true compared to the previous one, not true, we want to execute another chunk of code. So this one will involve an else statement. So compared to the previous one, the if condition, those symbols, we have another chunk of code else. So this one is actually called the false branch. Then when the condition is not true, then we will going to execute this one. So here the else statement, there is only one requirement, that the else is at the same line of the curly brackets, the previous curly brackets. So you shouldn't put like a enter key here, otherwise it will break the code. So it's I think that's pretty much about the if else, pretty straightforward. And sometimes you have nested conditions. Like for example, I always use the same expression in in almost like teaching every intro class teaching. So basically, like if it's sunny, then I will go to the beach, and if it's raining, I will watch the car. If it's cloudy, then I will just stay home. So basically, you can see there are multiple conditions, right? So you are judging whether the weather is sunny, rainy, or it's cloudy. So basically, you are going to have a lot of like judgment in the code chunk. So what you can do is that instead of just the if condition and the else, you have something in the middle called the else if. So this else involve another judgment, try to evaluate whether the second condition is true or not. So in this way, it's that when we first decide, okay, the condition 1 is not true, then we go directly to another judgment to judge whether the condition 2 is true or not. So if it's true, then we will execute this new statement. Otherwise, we go to the else statement. So basically, this is how we can write the nested if-else condition. So here is a small example, like you have a value x. You first judge, okay, whether it's a missing value or not a number. So if it's yes, then you print out, okay, x is missing. Otherwise, you will judge whether it's an infinite number. If not, then try to judge what are the branches, whether it's positive, negative, or exactly at 0. So this is a simple illustration about how to write the if-else statement. And sometimes we don't, if you have a lot of conditions to judge, you will probably see a code like this, like you have a lot of if-else, which is like clear right now, but it can be painful in some way. So for example, making your code unnecessarily long, and it's kind of hard to really, right now I think this is a good example about, okay, it's clear enough, but sometimes you don't have such kind of clear structures with many of the if-else. So it's more like the right-hand side. If you have a plug that have enough snots, then you don't really need the if-else statements like this, right? So actually, you can use a switch to do such thing. So for example, the expression, it will no longer just give you the true or false value, but you have several options. Like it can output certain values, and based on each of the value, you have different options here. So just take a look at this example here. Like we switch, we first try to convert the day, which is the numeric value, to a character, and we know that it can be ranging from 1 to 7. So for each of the options 1 to 7, you have a corresponding value. So this is how the switch function can help us to make the very long code to a much cleaner and also much concise expression here. So I think for this part, we already talked about the functions. So in the later part, we will talk details about the function. But right now you can see how the function structure is. You have a function name, you have a function body, and within the function body, you have the detailed commands. So another usage about the if-else is that you can, if you don't really want to write a very long code, you can actually embrace the if-else assignment to just a one line. This is usually used when you have a relatively simple if-else body. So for example, the statement, probably you have just one line of code. You can write it in this way. This way you have a much concise expression. And another thing I think is very important is the vectorized if else. So remember that we set the condition in the if statement must be a true or false value. It has the length of 1. But many of the times we want to, what we want to do is that for each of the true or false in a vector, we want to do the same thing to each element. So this way, we want to have some kind of vectorized if-else statement. So you can use the if-else function. Again, the condition here can be a single value, can be a vector for true or false. And what we will do here is that based on whether it's true or false, we will decide how to whether we are going to the true branch or the false branch. So in the later R Studio session, we are going to see how it actually works. All right, so before we go into the next part, I think we can take a 10-minute break from here, and then after we come back, we can then rest. So about the loops, I would like to also point it out. This is quite a common thing in our daily life. If you have ever heard about the song "Hey Jude," like the Beatles song, so you can see basically the whole lyrics can be written in this chart flow, and there is a section about the song that starts with na 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 na. So basically, it's kind of like a loop, right? So you are repeating the same thing all the time. So it's very similar in the R code. There's some of the instructions that needs to be applied multiple times, and we don't really want to write the repetitive code. This will be a waste of time, and it's really hard to maintain. So we want something to just like do the loops for us. So here in the R, I think there are three like explicit loops. The first one is a for loop. So basically here is like the syntax of the for loop. You have this for, it has a keyword of for, and with a parenthesis. The var in iterable is basically we are going to have this var as the iterator, and the iterable usually we use it as a vector. For example, we want to iterate through every element in the vector. So basically, we can just write it var in iterable in this way. And this whole part is a statement is a loop body. And after finishing like iterate through all the elements, this whole chunk of code will stop. So in the diagram, you can actually see the initialization, and we run through the code block, and after we finish, each time we finish the code block, we will ask whether this is the next iteration or not. If it's not, then we go back to the previous one, and then run the whole loop. And lastly, we will come to an end. So here is a small example I showed. Like you can construct like a for the I is our variable, iterable variable, and in this 1 to 5, so this will generate a vector for us from 1 to 3 all the way to 5. And for each of them, we were going to compute the j, which is the I square, and then just print out the values. So this will ideally give us the 1, 4, 9, like 4 is a 2 square, 9 is a 3 square, etc. So this is how the for loop will work. And there is also another loop called while loop. Basically, it will try to evaluate the condition first. Again, it starts with a while with the condition. The condition will give true or false value. Try to evaluate whether at this iteration the condition is true. So if it is true, then we are going to run the whole chunk of loop body, and after it's not true, then we will terminate the whole loop. So just try to remember, like when you write a while loop, make sure the condition can be false. Otherwise, you will always trapped in the true. So in that sense, the loop will never end, and you will run into like you will notice the running time is extremely long, and sometimes your memory will be eaten up. You have some kind of strange memory consumption steps in the loop body. So this actually happens to me when I was first learning R. So I was running a small program to do some data casing using the while loop. And suddenly I found, okay, every time I run the code, it doesn't pop any error, but my computer will freeze, will stuck at some point. And I check the memory, the consumption, and saying that the reason why my computer doesn't respond is that it ran out of the memories. So this is a very clear signal that my code has some kind of weird issue with the loop, and it just never stops. So compared to the for loop, because for loop you gave it a very explicit instruction about when to stop. Like you input a finite length of a variable, and then it will just stop after iterating through every element in the vector. But the while loop, the condition can be some implicit, and it has some kind of risk, higher risk to have the endless loop than the for loop. So the left-hand side, the picture here showing the logic about the while loop, as we said just now. And here is another small example that I think it's kind of a joke for the computational guys. Like when they are still alive, they will do three things: eat and sleep, and then write the code. So when will this loop terminate? Any idea? So when they are dead, right? Like when the condition is not true, they will terminate this loop. So otherwise, they will always do the same thing. It's kind of like a boring life. You only have three things in your rest of life to do: just sleep, eat, and code. All right. So I guess maybe although I try it out here, later we will use the RStudio session to really implement the while loop here. For now, I guess we can just move on to the next part. So there is another part loop for the repeat. So this is kind of different from any other language. For example, in Python or in C, or even in the shell script, you only have the if or while loop. But this repeat loop is something I feel like very specific to R. So what it does is trying to do the repeat the code block, and then they tries to do some logical condition evaluation. And if it's true, then it will end. It has some flavor similar to while loop, but later we will see they are quite different. So basically here, we don't really have the like explicit condition evaluation in the repeat chunk. But when you write the code, you will do something internally. Like you will try to evaluate whether a certain condition is true or not. If it's true, then you repeat the whole thing indefinitely. If it's false, then you jump out of the loop. So later we'll see. And besides the explicit three loops, there are also some kind of implicit loops, which can be summarized as the applied family. So again, like in any kind of programming we are working on, there are more than one way to do something. So for example, here we want to do a loop is that we want to iterate through all the elements. For each of the element, we finish some kind of computing. Actually, this can be done using a apply family, especially every element is doing the function or the operations for every element is the same, then the apply family will be a perfect choice for you. So here, I think there are many kind of functions that ends with apply. I just pick up 4 of them. If you are still interested about the rest, you can using the question mark to check out the apply, apply, etc. So L apply here is just like a list apply, and S apply is a simplifying list apply. T apply is a table apply, and if it's just apply, then it's a very generic version of apply. So what apply can do is that you can consider here. What we want to do is with a given list, we want to find out the unique values for each of the element. So for example, here, the 4, the unique value will only be one value, which is 2. So if you want to write it using the for loop, you will end up with the top right panel here. And if you just simply use the L apply, then you will actually have just 1 line of code. So this is a much more elegant way to finish the same thing. And besides, it will save you a lot of time in typing, right? You write a long code, which is kind of not beautiful. I wouldn't say it's ugly, but it's definitely not elegant, right? And typing costs you time and effort. So basically, we would suggest try to make your code as concise and tidy as possible. Just go for the apply option. So specifically for the L apply, it tries to again, like it will take the list as the input and try to apply a function to each of the elements in the list. So it can, the syntax is that you just specify X, which is the list, specify a function which works on the element of the list. Later we will see the particular example in our practice session. And there are also some kind of other kind of options you can supply to it. For example, if it's let me see, what will be a good example? Yeah, if your functions takes additional argument, you can use you can just specify it as additional argument in the L apply. It will do the same thing. So the S apply do a very similar thing to L apply, but it will try to simplify the results into a vector or matrix. So it's specifically if the return value for each of the elements in the list, the return value has the same length, then it tries to output either in the vector form or matrix form. For example, if the length is always 1, so which means each of the elements have a 1 value with results. So when you are summarizing the results, it will just give you a vector, right? And if it has multiple values, but with the same length, then it tries to return you with a matrix. So sometimes we would like to work on the simpler form, like a vector or matrix, rather than just work on the list. And if the return value is not always the same length, then you will just get the list. So remember that L apply will only return you with a list, but the S apply can actually have some kind of alternative options for you. And the syntax is basically the same. You supply X as a list and supply the functions. It will do automatically take care of the looping for you. And the T apply sometimes is very useful. So basically it tries to break the data into several groups and apply a function to each of the group. So just consider a simple situation that you want to consider, like for the male participant and the female participant, you want to calculate the average height. So you can actually just use a t_apply to do that. So for the x, which is a vector, the index is just a grouping factor. So basically, you can consider x is the height, and the index here is for each of the participant. It's a male or female, so it's index. And then the function here, as the example we mentioned, it's try to calculate the mean, right? So the function just be mean. So in the end, you will have two values, like the mean height for each of the group. So this is for the t_apply. It tries to do some splitting, and the t here stands for the table. And sometimes we work with the matrix, and we want to apply like some functions to the rows from the row wise or from the column wise. So we can use the apply function here. So the x can be either a matrix or data frame or a high dimensional matrix. And the margin here specifies either like if it takes a value of 1, then it will indicate rows. We want to apply some function to every row of the data frame or matrix. If it's 2, it indicates of the columns. We want to apply a function to every column in the data, right? So I guess here is like a small question that how to compute the row sum of matrix using apply, and how to do some kind of standardization of the rows of the matrix. Do you guys have any idea on how to use apply to do that? Any volunteer familiar with apply? So I guess yeah, the answer could be quite straightforward. For example, if you want to calculate the row sum of a matrix, you simply specify the matrix, right? And then specify the margin to be 1. And the function is just a sum function, SUM. It's a natural function in R. And if you want to standardize the rows of the matrix, so this usually happens. For example, you have a gene expression data, and you want to convert all the values, like to have a mean 0 and standard deviation 1 to try to normalize the data in some way. So what you can do is that you simply try to compute what is the row means, so which is finished in step 1, right? And you also try to compute what's the standard deviation for each row. What you will do is just replace the mean, replace the sum with SD. So again, like if this is a sum, then try to calculate the means, just dividing by the number of observation, number of the columns. And after that, you can just subtract from the original x, like x minus row mean, and divide it by the row standard deviation. So this will eventually give you a mean, the final result. So you get, will have for each of the row, we'll have mean 0 and the standard deviation 1. So this is like how we can make the data normalize in some way. So if you are working with gene expression data, you probably will see this much more often. All right, so that is about the loops. And the next topic is about functions. The functions you can consider is just like a machine that it can take some input and then it will give you some output. So it's just like a mapping from the input and to output. So it's kind of different from the previous ones. Like we talk about the variables or data structures, which are just containers to store the data, and the functions can be considered as more like an action. Like what are you going to do with the data? So it's instead of it's like a container over there, you are actually doing something from there. So here the input and output can be optional. For example, if you are just using a random number generator, you don't really need to specify input. It will automatically give you the output. And sometimes we don't really want any output. So for example, but this is the kind of like a strange case. We still want something from the function. But usually you will have both input and output. So there are some kind of built-in functions we have seen before, but according to the variables we work with, we can separate them into some kind of like string functions. We have seen those before, like the paste function. The mathematical functions, we see those root transformation, square root transformation. Those are all belongs to mathematical function. And there are also some kind of statistical functions, like for given vector, what's a minimum value, what's a maximum value, and what's the means, what's the sum, etc. So here I'm just listing some of the frequently used functions from the mathematical functions, statistical, string, and also some other very useful functions. For example, the unique. So basically consider you are collecting a set of data and you want to know how many unique values over here. You can use a unique. So it's kind of like a converting a list to set in Python, like because set, the elements in set cannot be duplicated. So it's has some flavor over there. Like you are using a set operator in Python, it's in R, it's using the unique. And for the statistical function, I think sometimes you are going to need it, try to compute the mean and the standard deviation. So you can report the confidence interval. And if you are interested about the correlation between two variables, you can simply use the core function. And sometimes you are curious about the distribution, you can try to use the quantile function. So I think some teachers would love to use the quantile because when they calculate the final score, they want to do some quantile, like try to say, okay, at what kind of score, like how many of the students will receive an A, will receive a B, etc. So this quantile, I think they love to use it. So besides that, I think most of them are quite intuitive. You can see the function name is actually meaningful. So I would encourage you guys, if you are going to write a function, try to name it meaningful instead of give it a random name like x0, x1, like those, like you cannot see what the function is doing by just looking at the name. But here are the good examples about the namings. So those are the built-in functions. If you want to write your own functions, the customized functions, you can write in this way that you have the name of a function, right? And you have the assignment, the assignment symbol, and you have a keyword function with the parentheses. Within this parentheses, you are going to input the arguments you want to put in, and besides that, you have the curly brackets enclose the function body for you, and usually we will have this return value, which means what's the output this function is going to deliver. And here is another example that actually doing some simple thing that you have input. So basically we give a name to this function, and it will take two values. One is x, one is y, and the results will be just the square root of x squared plus y squared. So remember that here we don't have a return value, right? So in R, if you don't include a return, then it will try to output the final step as a return. So this is different from Python. I think in Python, if you don't include a return, it will just don't output to you anything. So it will be a none. Okay. So when you define the functions, you can actually provide the default values. For example, you can when you define the functions, you can put x equals to some constant. This constant is your default value. So when you don't specify x, then it will automatically use the default value for the following computations. And when we call a function, if we don't use the name, if we don't name the argument, for example, when we call this function, we just specify the hypotenuse 10 and 5. We didn't specify hypotenuse x equals to 10, y equals to 5. So just with the numbers, then this R will match them based on the positions. Like take the first value as x, takes the second value as a y. So this is I think it's also the same thing as Python. And sometimes you will see those like 3 little dots in this argument part. So this simply means contains all the arguments that are not matched by the position of the names. So this is usually useful when you have a really dynamic argument setting. And especially when you have for example, sometimes you want to have a function within your own defined function. And that function can take some arguments. So you basically can you can put this three little dots to the arguments. Anything passed and not used in this function probably can be used with the inner function, the another function you called within the function body. And if you want to see the body of the function, you can use there is actually a function called body. So you put the function name as the argument in the function body, and then you will see the content. You can see what code within there. And as I said that without the return, the next value calculated in the function will be automatically returned. So even though you don't include a return here, it will still give you the results, the square root of x squared and plus y squared. So yesterday we also talked about the variable scope. We mentioned it in the assignment, but we really don't touch it. So the variable scope is that the places which you can see the variable, you can use that variable. So for example, when you define a variable inside a function, it's usually called a local variable, and the rest of the statements within the function can use it. But it cannot be seen outside the function. Instead, like variables defined in the global environment, like outside the functions, can be seen from anywhere, like within the function and within the function's sub-function. They can always be seen. So there is a hierarchical step over there. So another you can consider like in this function the y, because we don't have a y definition within the function body. So actually y is treated as a global variable, and if there is no global variables out there, these functions will return an error saying y is not found or something. So the actual logic about R is that it tries to, when it runs this function, it tries to find the variable. For example, find the y. If they cannot find within the function the current environment, it go up to the parent. So like the function that enclose this function all the way to the global environment. So I think for the question, I just answered that. The global environment usually cannot access the local variable defined within a function. So this is like try to separate things from the global to local, so they don't interfere each other in some way. All right, I think we can do some small practice. If you open the R Studio, you can try to paste this code. Like you can type in the code in the command line to really clone this repository to your local computer. So it's https github.com. This is my username, wbvgo, and this is the repository link, qcbio with a hyphen, and capitalize the I intro to R, the feed. So what you can do is go to the R Studio, and if you open it, you'll see the console, like the console section. There is a terminal. So the terminal actually is the shell part. So you can just clone it when you type in the command git clone. It will try to pull the repository to your local computer, and after that, you will see, like before that, there is no qcbio folder, right? So after running that, you will see there is a qcbio folder, being downloaded to your computer. So another way is that you can try to access the folder from the right panel files. Let's see the qcbio intro to R, and you will see the 3 different files here. We can just open the R Markdown file. So this one is different from yesterday. So yesterday you just create a R script file. So for example here, it will try to, for example here the one. Close. So it will have it will end with R, but this file is R Markdown file. It will end with RMD. So how to create this file is yeah, it's not there.
So I went to terminal and then I typed in github.com.
It should be GO. Can you double check the spelling? Yeah. So if does anyone else has any questions about this part? Yeah, maybe we can take 2 minutes to finish this part. So I hope everyone is able to download it. So again, so first we need to make sure the typing is correct. Let's see what's okay. Right now just this type of lines, the writing is correct. And if you already downloaded it and then you run it again, then you will see this error saying there is already an existing folder there. But if you are just a git clone for the first time, you should be able to download it. And if you have issues with your computer, you can try to use the qcbio computers to access it. And if you are using the Windows operating system, another alternative way, if you don't, if you cannot make it run, so basically you can go to the website, just copy the HTTPS, and then you will see the files here. Click the code, and you will see the download zip, and then you will just download the file. After downloading, you can unzip it to extract the files here, and you can see what files included. So you can just double click the file to open it in the RStudio. So I guess right now we already have everything we need, just the R Markdown file. So again, like this is a new file format for us. It's R Markdown, so you can try to create your own R Markdown by clicking this option. After that, for example, you can create one for the test. After that, you will see a file, and basically it has the same format as we have here, right? And it has some kind of documentations over there, which I will later briefly mention about it. So let's go back to the file. So here is the outline. So everything started with the pound here will not be a comment. It's actually a title line. So for example, here you can see the outline, right? Outline and the day 2 pounds is actually a subtitle. So the number of pound symbols you have denotes the rank of the title. If it's only 1 pound, like here, it's a title line, and the 2 pound is the subtitle, and maybe you can add 3, 4, etc. to make it like a hierarchical title. So here is our outline. We are going to learn the data structure and the flow control, etc. And lastly is about the data wrangling skills. And for the R Markdown usage, there are 2 tips. One is that we see here like 3 ticks, and also with the curly brackets with the R, and end with 3 ticks. So basically, this will give us a code chunk. So everything you put inside can be an R code, and you will see this little like triangle here. So this means run the current chunk. So if you run it, it's just like a regular R code in the R Markdown file. So the advantage of R Markdown file is that you can use the Markdown syntax to write documentations instead of using the comment line. And we know that it's kind of limited, right? But in the R Markdown, you have different format, you have different power of expressions. So we usually I would prefer using R Markdown instead of just using an R file. So go back to the tricks here, is that you can, instead of just typing everything, for example, R, and then end with a 3. So this will give you the code chunk line. You can simplify this process by pressing the control command with Alt with I. So let me try it here. I think it's shift control and command with my control option. Yeah, so if you are in the Windows setting, I think it's a control and Alt and I. And if you are in the Mac OS setting, you should control option and with I. So because I think Mac OS named the Alt key as the option key, so it's slightly different. So this is just a shortcut to create a new chunk line, which will be really helpful when you need to insert a lot of codes. And another small trick is about the comment trick we have mentioned before. If you are really interested about the Markdown usage, you can refer to the cheat sheet and also refer to the resources I put here, because this is kind of like an advanced usage of R and R Markdown. So we are not going to too much details about it, but the take-home message is that it's a very useful format for documentation, and also run the code in the meanwhile. So here, the very first thing we do is try to create a list, okay? And we have the, just as we did in the slides, we create a list that contains 4 different types of variables or different types of values. So after that, you can just run this line of code to really see what's inside. There are 4 elements. and each element can have different types. And we can try to assign the names to the current list using the names function. So after that, you will see each of the element they are associated with the name, right? And you can see the length of the list. You can try to access the first two elements using this index. So again, like using single brackets, it's just return another list for you. And if you want to access the specific element within the list, you should use a double square bracket. For example, for access the first element, which is a vector of a numerical vector. And you can also use the names to do the indexing using the brackets. This one will just return the first position, like the element in the first position. And this one will return the element with this given name. All right, let's run it. And besides the double brackets, you can use a $sign, as we mentioned in the slides, to again index the list. So for the combine, we can use a concatenate symbol, the C function, input two lists. It will try to give you the combined list. So some of them have the name, and some of them don't, just as the original list did. So if you want to remove an element, as we mentioned, you can assign this null value to a particular element. For example, here we assign the null value to the element named B. So after we run it, we will see that compare this output to the previous output, the B it's gone, right? It's missing right now. So everything, this is a nice trick to remove some element in your list. Right, so for the data frame, it's pretty much similar, that you can create a data frame using the data frame function with specify the variable names and the values. And if you want to give it a row name when creating, you can specify the row names argument by passing the string vector to it. So after we run it, we'll see this is how the data frame looks like. Every row is the observation, every column is a variable, and each of the column, they should have the same type of values across the observations. Like for example, X, they are all character, and Y, they are all the numerical values. So to access a dimension for data frame, you can use the n row, n column, and dimension. It's the same as a matrix. And if you want to indexing, as we mentioned before, you can input the access it using the matrix way, or access it using the list way. So those are well documented in the slides. And if you want to access the first row or second row, so you can just leave the column as empty. And if you want to just access the second variables, you can leave the row part as empty. So it will automatically select all the elements for you. So this is the output, like if you access from row 1 to row 2, and from the second variable to the third variable, it will return you with a smaller data frame. And if you access the first row at the second line of code did, this is the results. And if you specify just one single column, it will actually return you with a vector. And the last line is also a vector, because we just access the first column, the X column, and then try to index that vector from the 1 to 2. So which gives us A and B here. So this is about the data frame creation and the indexing. And sometimes we want to split or subset the data frame based on some kind of a condition. So for example, we want to select the rows whose value of y is greater than 5. So we can first compute the index true or false for each of the row. Just try to judge whether the value of y is greater than 5, and then use the index to subset the data set data frame. Alternatively, we can use the subset function as we mentioned in the slides, that you can supply the data frame at the first argument and then supply the condition judgment at the second one. And if you don't specify the set one should be the number of the columns you want to output. If you don't specify that, so you will have all the columns output. And here is another example about the transpose. Again, like we can check the data frame value from this top panel. You can just click it, and then you will see the results over there. And so if we transpose it, then what we will find is that everything will be a string now. So this is expected because if we convert it, then the current rows will be columns. So, but we know that each column, they must have the same type of values. So for example, here we have the A, which is a string, and then 1 is a numeric, but false is a bool type. So basically, they will convert it to the character or string here as A did here. So this is why we see all the values will be converted to a string type. And the next part is combine the data frame either by column. So we have 2 copies of A data frame. So we combine by column, or we can combine them by the rows. So if we combine them by column, then we'll double the number of columns, 5 times 6. If we combine by row, then we double the rows. It should be 10 by 3. So which is here, showing here. So another thing is about the column sum or the row sum. So here we have create a new data frame called the BDF. So if we want to compute the column sum, so basically it will calculate the sum of each column, each variable. And if we compute it row sum, it's just try to compute the sum of each row, like 2, 4, 6, 8, 10. So this is exactly what we get after calling the row sum function. And the next part for it is for the flow control. First, I want to just say this code. It's an example on the slides that we have a value x equals to 10 and goes through all the if else part. So basically, it will judge whether x is true, it's missing or not. Then judge whether x is infinite or not. And judge whether they are positive or negative or 0. So if we run it, so hopefully we should get the results as x is positive. So this line of code is it's just printing the string here out to the terminal. So we can run it from here and see the output is x is positive, and we should be able to understand like x is 10. So when we have this judgment, it will be true, and then this line will be executed. So it's really really straightforward. And the switch function, here we still have the examples on the slides. We defined two different functions. One is using the nested if else, which is pretty known. But if we switch to the switch function, we can write a much shorter code, and the results they give should be exactly the same. So because I've already explained the logic in the slide, so I will just run it from here. And besides the if else, we also talk about the one-line if else statement. So this will again like make our code pretty concise. So for example, here we have a value of a and judge whether a is greater than 0 or not. So if it is greater than 0, we assign positive to b. Otherwise, we assign non-positive. So we can write it in the if else like a curly brackets version, but I think this one line just do the same thing, but it has a shorter expression. And for the vectorize the if else, so I would like to ask you guys pay attention to this one. So basically, when you try to run it, it will actually report an error saying, okay, the x must be x greater than 0. This condition should have length as 1. So it's only have the true or false values. But right now, because we have the x to be a length of 2, right? So when you compare whether they are greater than 0 or not, it will give you a vector of true or false, and the vector has a length of 2. So this will cause some issue with the if else, because the if condition, they just expect either true or false. It's just a length of 1. So to solve the problem, we should consider to vectorize the if else. So using this if else function statement here. So here x can be like a vector of length 2, 3, etc. It doesn't really need to be length of 1. And what it did is trying to judge, okay, for the first element, whether it's greater than 0 or not. If it is greater than 0, then output the positive. Otherwise, output the non-positive. And so basically, it will do the same thing for each of the elements in X. So we can just try to run it from here. So we can see that the compared 0, each element with 0, either it's positive or non-positive. This is a really important trick. If you have multiple, if you want to vectorize the if else, you should consider using this one. As a vector here. Yeah, so basically every time we evaluate this condition, it's always a vector. And the if or else condition here, if it's a vector of length greater than 1, it's not legal. So basically the R will interpret as that there is some error going on. And for the next part, if else, this one. So when we evaluate it, like x is greater than 0. So this one will return you a vector, right? The vector of length of 2. Either like the first one will be true and the second one will be false. So what this function did is that based on the true and the false values in this condition, length of 2 condition, and then for each of them, they will decide whether we are going to output positive or non-positive. So does that make sense in some way? Yeah. So I think the if else. So basically this line of this function is different from if and else. So they are just like a totally different thing, but they look alike. Yeah. Yeah. So the next part is about the loop. So we talk about the for loop. We can use this line that it's a for and a parenthesis, and using a variable in a vector. So this 1, 2, 5 give us a vector. So we can try to run it as expected. When I equals to 1, the j will be 1. When I equals to 2, the j will be 4. So the largest value of I will be 5. So when we finish this computing of I equals 5, we will get j equals 25, and then the loop will stop there. And if we want to try to like rewrite the for loop from here using the while loop, so what we need to do is just from the I equals to 1 all the way to I equals to 5. So we need a statement that try to judge whether I is smaller than 5. Okay, and within the body it's the same thing. You compute j and then print it. But the important thing is here that we need to add up 1 each of the iterations. So if you didn't, for example, you comment this 9 out, you don't update I, so the I will always stay at 1. So when you run the code, it never stops because I will never be beyond the 5, right? It's never going to be greater than 5. So it will always run in your backend. And here is another example of doing the same thing using the repeat loop. Still, it's very similar to the while loop. The difference is that the repeat, they don't contain a condition in the outside the loop. Instead, you need to incorporate judgment, a condition yourself. Like if I greater than 5, then break. The break here is just trying to jump out of the loop, like terminate the current loop, and then move on to the next following code. So we can run these 2 lines. We see the output is exactly the same as the for loop. It's also the same thing for the repeat loop. All right. And besides that, we also talk about some advanced loops using the applied family. For example, here we have the B list. So the B list, we can check the details. Just click in the data here. You see the values. It's a list of these 3. The values will be 1, 3, and 4. So if we try to use the L apply B list with the square root, so basically we are trying to compute the values for each element by just taking the square root of the value. So when you run it, you will see, okay, the first element we get will be 1. The second one is 1.73, which is around the value of square root of 3. And the third one is 2. So again, you should notice that the L apply always output a list for you, all right? But if you are going to use the S apply, because every element's results have the same length, so it's just one single value. So you expect the results will be a vector, right? So this is no longer a list, but a vector for us. And here I show another example using T apply. So basically here we have the value from 1 to 6 and the group value, which you can check the group. So basically it's just like for each of the elements here, we have a group label, whether it's 1 or 2. So here the rep, we mentioned it in yesterday's lecture slides. Each equals to 3 means we want to repeat the 1 for 3 times, repeat the 2 for 3 times. In the end, we will get a vector of the first 3 elements will be 1, last 3 elements will be 2. So group and the value, they have the same length. They have the one to one corresponding corresponding relationship. So when we use the t-apply by specifying the value and the group and just call a sum function, what it will actually did is trying to split the value based on the group variables. For example, here we split the first three and take the sum, and then we split the last three as another group and take the sum. So in the end, we should expect the results will be 6 and 15. So which is pretty expected. And lastly, is about apply function. We apply the sum to the rows. So for example, here we have a matrix, and we want to compute the sum of the rows, which will be 12 for the first row. So this is how we can use it, do it in apply. Specify the matrix, specify the margin, which is 1 stands for the rows, and specify the function, which is the sum. So this will give you the results, which are showing as the first element as the 12. So I think this part is about the function, about how to create a function. And here we can assign the default values to the function. And if we don't assign the default values, but we call the functions and didn't provide what is the x and y, so it will give you some kind of error. If you have the default values within that, so when you don't supply anything, it will use the default values for you. So when you run it, they will still have output. All right. So, and another thing is that if you only, if you are just using another variable from the global environment, for example, the y is already given in the global. We didn't define y in the function. So based on what it does, that it will you supply x to be 2, and then the function will find the y in the global environment, which is a vector, and you try to compute the product. So it will compute 2 like times 2 for every element in the y. So this is why the reason we get a result here. And for the body, so we can see what's inside the function, just using the body function. So this is exactly the definition we have here, right? So they are the body can output the contents of a function. So I guess we can take another 10-minute break, and when we come back, we move on to the next part. So I guess yeah, I hope that will be a useful practice to get you guys familiar with the operations with the list, data frame, and the functions and loops, etc. So next we want to move on to the packages or the data wrangling in the tidyverse world. So basically, the packages we are talking about is that it's something we can directly download and then load it into our environment. As a result, we can use functions in those packages. We don't really need to write our own functions. And here, it's like the number of packages on the prime and across the years. So basically, you can see that at the very beginning, there are very minimum packages over there in the early 2000 when R is first invented at that time. But right now, it's over 20,000 of packages over there. And you can consider that there are many genius people out there who work very hard, try to develop packages, and we can just use it. So we don't really need to build everything from scratch. We don't really need to implement everything by ourselves. So you can consider it's like we are standing on the shoulder of the giants, and hopefully we can see further away. So this is the general rule that you don't really need to, usually there is no need to reinvent the wheels, just use it. And if you feel it's not good to use, or it has some flaws, issues, just to try to improve it if needed. So the idea that we don't reinvent the wheel is that first, your implementation is not guaranteed to be correct. And usually that's probably the case. And on the other hand, your implementation probably is much slower than those well-established packages, because those packages, they already do a lot of testing. They find every way they can to optimize the code, or even use some kind of advanced programming technologies. So I actually have some kind of personal experience when I first learned how to program in R. And I was working with a data frame, maybe several thousands of lines. And I tried to create a new column to the data frame, and then just using some kind of a string computations. So I try to run it. It doesn't run. It doesn't give an error, which is a good thing for us, right? So at least the code logic is smooth. It's okay. But it takes around 2 hours to finish running. So this is definitely something going on, some issue going on with the code. It's so slow that I cannot bear it with it. So later I just abandon the code I wrote. I don't try to reinvent the wheel, just use a available package in the tidyverse. So basically it can finish within seconds. So this is very giant improvement in terms of speed and efficiency. So I hope this kind of a small story is useful, that you whenever there is a good package, you can try it first. If it doesn't work for you, then you consider to implement your own, but try to search first. So how to install the packages is that we can use the following code, install packages with the package name. I guess you guys can just try to copy the first line and run it in RStudio. So this one is actually what we are going to use in maybe later today or tomorrow. That is the tidyverse package is set. And if you want to update the package, you can use the update package. And if you want to uninstall the package, you can use the remove packages. So this will give you some intuition about how to install packages from the command line. So another option I mentioned yesterday is that you can use the RStudio interface. On the bottom part, the packages tab, you can install the packages from here. So just type in the package's name and install. It will do the same thing as we install using the command line. So besides that, yeah.
So when I try to install packages, where is it?
Have you included the quotation?
But I didn't try the other way also when I put some packages. So that one,
which one you talk about? This one?
I put it in the search bar. I think.
Oh, okay. Which one? Oh, search bar. I see.
Search bar, and then
yeah.
So
if you,
it's already downloaded.
Yeah, if you see the records here, you already downloaded it. Okay, so there are two options about installing the packages. Remember that when you are using the command line, you should put a string there. Otherwise, it will interpret maybe as a variable. So you get the issue of variable not found error. But the idea about install and load is that when you install it, but it can, the package will be on your own computer, but it's not necessarily loaded into your environment. So the next step is to try to load it. So library tidyverse. After using this line, you will be able to use the functions in the tidyverse. So if you want to unload a package, you can use the unload namespace with the packaging name. So install and enable reload is I think these two figures is very very vivid. So install is like you are installing a laptop to the, like you do some kind of hardware operations here. And the enable reload is more like you are like putting a switch. Okay, if you want to turn on the light, turn off the light. So this is basically the library, the node library works. And sometimes you want to check the package version. This is usually the case when you found that, okay, your code runs pretty well with the older version package, but they somehow have an error or have an issue with a newer version. So you want to double check whether the version matches. So you can use the packaging version with your package name. It will output the versions. And if you use the session info, it will output all the packages versions and also as well as your computing environment basic informations. And if you are advanced R user, you want to write your own package. So basically this package is actually just a bundle for code, data, and documentation and all other related files. So it's invented to share the code to other people. But we're not going to go too much detail about this part. I think it's more like an advanced version of R. And if you feel really interested about how to write your own package, like you want to contribute to the bar product, you want to be part of it. So try to consider write your own package. And you can find how to do that using this reference book. I put a reference link here. You can access it for free. So the next part, after we know the library, is about the data wrangling part. So what is the data wrangling? It's just a process that are converting our raw data into a useful form for either visualization or for the modeling. So usually we are comfortable with the tabular data, like you have the data frame, etc. But many times in your raw data, they are not ready for the data frame. So you need to find a way to first import the data, and then you clean the data in some way. And then sometimes you want to transform from the long format to wide format, etc. So basically this whole process is called the data wrangling. And for the purpose of computational and for the purpose of work efficiency, I would suggest try to use a tidyverse instead of doing everything using the for loop, using like the other like basic programming techniques. So basically, I guess the tidyverse will save you a lot of time and effort in doing this data wrangling work. So the tidyverse can, as we mentioned before, it's not one single package. It's a set of package. It's a two boxes. So basically, it ranges from the import data to exploratory of data to all the way to communications. For the import, you can have those options. And for the explore, we can either clean the data or manipulate the data, like create a new columns or filter out some rows to all the way to the visualize our data, like doing some exploratory analysis. And for the communication, we can use the tidyverse packages to model or even to generate the documentation. For example, for the R Markdown, we just mentioned, it's actually coming from a package. And if you want to create a website, like a data portal, so you can consider using Shiny. And sometimes it's really useful to have those documentation. So everything you wrote, other people can directly see from your code. So it increase the transparency of your research, and also increase the reproducibility of your research. Like you are not playing with some randomness, but everything is encoded in your code. Other people want to follow your work, you can just copy your code and then play with it. So I think this communication is quite important actually. And if you go to the Stack Overflow and try to find the text with R, you will actually see currently the questions is like so basically here I just plotted over the years what's the rank of those topics related to R. So you can see the ggplot2 and all other versions of tidyverse packages, they're always on the top. So which means maybe people are shifting from the base R to tidyverse because it's very powerful, and you can actually have a lot of community, like strong community support from the tidyverse. And for the part of a data analysis project, we actually have such kind of route that import data tidy and transform. So this will be exploration. It should be like a circle. And then lastly, when you finish every analysis, you communicate with us with other people. So tidyverse have those packages responsible for each section of the route in a data analysis project. And we are going to learn some of them, not all of them, because as you see that it's too much for a 3-day workshop. And I think those are we will cover the very basic of those uses. And for the rest, you are more than encouraged to explore by yourself. So the very first thing to do data wrangling is try to import your data from a file, for example, the txt file or the comma separated file into your R object, into the R computing environment. So the very first thing you need to do is to read the data, right? Read the data from the base R tidyverse to just save it into a data frame or some other list. So here I listed what functions you can use when read the data. So basically, you are going to specify the file name where your data located, and specify what other argument, whether this file contains a header or not, and what separator this file used. For example, if it's a CSV file, so basically the separator should be a comma. If it is a TSV, means tab separated file, so it should be a \t, which stands for 4 spaces. So it's a tab key. And you can also try to specify all other things, row names, like whether you want to convert a certain column or a certain row as a row names, and columns names, whether you want to convert a certain row as a column names. So basically, this is when you read the data, you have those options to really make your data as a tidy version. So there is another option called the escape zero. So sometimes we have comments at the beginning of our files. So you can try to use the escape to escape the comments, and after the several lines, and then you really started to read the file as a data frame. So basically, these are the options you can use. For the read R, which is the member of tidyverse, they have a similar functionality, but basically I think the job is pretty similar. The arguments is also similar. So here, although I just listed the read table, but but I think the logic is pretty much the similar. So this is about the read data, and after you have the data, you finish all the processing, cleansing. You want to write the data to your disk, so you can just use these functions to do that. And I'm not going to go too much detail because they are pretty similar. The argument, the syntax is pretty similar. You can use the question mark to check the usage. So besides the writing to a TXT file, sometimes we also have some intermediate data to use. So for example, one of my favorites is RDS. So you can consider it's very similar to Python's Pico module. So you can actually save some data into an intermediate form, and when you like want to use it again, you can just load that intermediate data into your environment. So what you can use a read RDS or save RDS to do that. Simply just save this object to this RDS file, and when you load it, just put the path, file path, and then assign the read RDS results to a new variable. So basically, this is very easy, and it's pretty similar to the Pico if you have ever used it in Python. And the next part, I think it's manipulate the data. So I think this is pretty important in every data science project, and also in every data realization part, because usually the ultimate goal for data cleansing or data transformation is to make figures, right? For your papers or for your presentation, you want to make figures, and usually once you have the right data in the right format, aggregated in the right way, the right visualization is obvious. So which means once you have those data ready, the figure is pretty easy to generate. And usually, I think the data is the most time-consuming part. When you work on your research, because the data you actually have a lot of issues. It's not like a very tidy version of data. You have the missing values. You have the unstructured data. You need to come up with so many strategies to solve the issue. So manipulate data, I think, is pretty important. And I probably can just skip some of the recap. So I think we already covered in the first this lecture about the variables. Basically, we have a new numerical variable. We have the categorical variables, which is a discrete type, and we know the factors and how to create the factors. So this is the data frame. It's a generic data object we introduced in the beginning of this workshop. So the data wrangling functions is trying to usually work on the data frames to manipulate the observations, which is the rows, and manipulate the variables, which is the columns. And sometimes it will also try to do something with the values. So here, I listed several functions, which we are going to learn later on. But if you want to know more, there is a cheat sheet you can check. So besides these functions I listed, I talk about there are many more functions that might be useful to you. For manipulating the rows, we can consider first, it's trying to do some filtering. So basically, not all of the observations is useful, or not all of them are interesting. So you can consider try to keep some rows that satisfy certain function, that satisfy certain conditions. So the filter, the first argument in the filter is a data frame, and the second one will be some kind of logical vectors. So the logical vectors can be obtained by the comparison operators or logical operators. So what the filter did is that you have the original data frame, but you use some conditions to pick up the rows that you are really interested in. And then after that, you will just extract those data. So basically this filter will just try to shrink your data to the useful part. And there is another function called the arrange, which orders the observation according to your variable. So for example, you have a data frame, you want to order the data frame based on the age of a person. So this arrange can help you solve that. Again, the first argument will be a data frame, and the second one will be the argument of the variable. And it actually can be a function of variables. For example, you want to sort the data based on the ascending order of age or descending order of age. So basically, you can use the function of variables to do that. Just like, for example, the second variables will be descending this function with the age as the argument inside. So it will do it in the descending order. Then there is another option for the by group. If it is true, then it will first group the observations into different small groups, and within the group, it will try to do the sorting or arrange. And if you have a lot of data set, data frames, you can consider to bind the rows. So this will try to bind any number of data frames by row. So it's similar to the R-bind, but we have like a different version in the tidyverse universe. So besides the rows, we sometimes also want to do something with the columns. So for example, one typical thing that we want to select the columns that satisfy our desire. For example, we want to keep a certain column, or we want to drop certain variables. So again, the first argument will be select, and second and the subsequent will be some expression, the encoded expression separated by the comma. So later in the RStudio, we will see how to use it. But for this one, I think there are some key points to note. One is if you have multiple variables to select, you can use the wall of supplied by a vector of a character vector containing the variable names. And sometimes your variable names will start either with a certain pattern or end with a certain pattern. So you can use a start with or ends with to do the selection. And you can also use a where function. So basically the where tries to do some kind of computing itself, return whether this variable satisfies this condition or not. And then eventually it will select the columns, the variables of whose value is true. And besides that, you can also try to use a compound condition, like the logical condition when you are combining several conditions together. Like because, for example, here for the true, you can consider, okay, we use different criterion to select the columns, and you use the and or operators to do this, to combine the conditions. And besides selection, sometimes you want to create new variables. For example, you have the height and the weight data for each individual. You want to compute the BMI body mass index. So this mutate can be used to solve that problem. The first argument will still be the data frame. And the second one will be named value pairs. For example, you want to compute the BMI equals the height, the weight divided by height times some constant. Then you can just write it in the right hand side. So basically, it's a name and value pairs. And the value can either be the length of one. So for example, you just mutate a new variable to be a fixed number, for example, one, like the group ID. So you can consider the vector you input, it's just a length of one. And it can also be the same length as the whole data frame. as I said, like the BMI for each individual. So basically every person will have a value. It can be considered as the same length as the data frame. And if you don't want to have a column, you can again use a null trick to remove the column. So you can also use a select, but a mutate can also achieve the same thing. So besides that, sometimes we want to combine the data frames by column. So besides the binder rows, we can have some kind of advanced binding, which is the join functions. So based on it here, for the inner join, it will try to only consider the observations that is shared between two data frames. For example, here 1 and 2, only 1 and 2 is shared. So when they join the two data frames, they only keep the two observations and try to use it as an anchor. Use the identifier as an anchor, and then create a new data frame by joining them together. So there are also some other functions for the for join. So basically every observation is considered, and if it's not found in one data set, it will have a missing value, which is showing empty here. And we can also use the right join. Basically, the left join will just using the left hand side data frame as a reference, and then fill in the rest values for the left. And similarly, the right join is just trying to have the right data frame as a reference and assign the left data frame to the right. So here is like a full list about how to use it and what's the consequence of a left join, right join. It's also in that cheat sheet, so you can check it later. And I guess we are running out of time for today, so we will leave the RStudio part for tomorrow, and for the reshaping data, we will also talk it in tomorrow. So I think that's all for today. If you have questions, I'm still here for the next 5 minutes. If not, you are ready, like you are free to go.